We're now going to look at more complicated expressions and how we can simplify them. And to do this, we're going to now use our whole toolbox of exponent laws or exponent rules. Let's look at this first example. So looking at these two brackets, they each have a exponent applied to them, which means we have powers of products. So for each set of brackets, I'm going to have to apply that power to each part of the product in the brackets. So that's the power of the product rule. It's the first thing I have to do. And so c to the 4 to the power of 5, that's c to the 4 times 5 is c to the 20. And then d to the 10. And then in the second bracket, I have 3 to the power of 4, which I can't do in my head just yet, so I'm going to think on that one. And then c to the power of 4 and d to the power of 20. Now what I have is a bunch of powers together, all multiplied, and now I can use my product rule, which is I can multiply my powers with the same bases. So first I'll start with the number part, 3 to the power of 4. And you can do it in your head or you can do it in your calculator, but you'll get 81. And then c's, I have c to the 20 times c to the 4 is c to the 24. And similarly, d to the 10 and d to the 20 is d to the 30. And so there's my simplified expression. Next up, I have a fraction, but I have the same first task, which is I have all these brackets with exponents, and I have to apply these in to the brackets before I can do anything else. So a to the negative 2 to the power of 3 is a to the negative 6. A to the 2 to the power of 4 is a to the 8, so that's in my numerator of the fraction. And then again on the bottom I have a to the 4 times 5 is 20. And now I can see that I have a bunch of powers with the same base, a, and I have some more simplifying I can do. And so I can combine these any which way I want, but I'm going to start just for myself. I see a to the negative 6 and a to the 8 on top, and I just feel like that would be a really easy place to start simplifying. So a to the negative 6 times a to the 8. Well, it's negative 6 plus 8 is a to the 2. That's using my product rule. And then I have over a to the 20. So now I want to simplify this fraction, and it's always good to have your powers or your exponents be positive. So I want to leave my positive exponents on the denominator here. So I'm going to cancel 2 of the a's on top with 2 of the a's on the bottom, leaving me with 18 on the bottom. And when I do that, what gets left up top? Well, if you don't see any numbers there, there's an invisible 1. So just because everything in the numerator canceled, we still have a 1 up in the numerator, and then we have a to the 18 in the denominator. So in these previous examples, the first thing we've had to do is jump in and apply any exponent into each part of the product in the brackets. But looking at this one, there's actually something I can do ahead of time, which is that the items in these brackets, these fractions, can be simplified before I get started. So that's what I'm going to do first. I'm going to simplify each of these brackets. So this first one, I have 3 in the numerator. I have x on top and x squared on the bottom, so that x on the top cancels with one of the 2 x's on the bottom, leaving me with a single x in the denominator. I have y to the negative 3 on the bottom. I'm going to flip that on top so I can combine it with the y squared and have positive exponents. So I have y squared times y cubed, and all of that's being squared. And then my second bracket, again I have 9 on top, so the number part has nothing to do. I have another cancellation with my x's, leaving me with a single x on the bottom in the denominator. And this time I'm going to flip my y with the negative exponent down into the denominator to make it positive. So I have y squared times y cubed. And all of that is to the power of negative 1. So now I'll just go through and combine those y's. Just to tidy things up before my next step. And now my next step is going to be, now that my brackets or my fractions are as simple as possible, now I can apply these powers into each piece of the fraction. So 3 squared is 9, y to the power of 5 to the power of 2 is y to the 10, x to the power of 2 is x squared. So that's my first fraction. And my second fraction, the negative 1 just flips it. So now I have x to the power of, x times y to the power of 5 all over 9. And now I have two fractions multiplied together. I can simplify anything that cancels, or cancel anything. So those 9's cancel, because I have 9 on the top, 9 on the bottom. My x's, there's a bit of cancellation going on. I've got 1 up top and 2 on the bottom. So that 1x on top cancels with one of the x's on the bottom, leaving me with just one single x in the denominator. And then my y's are going to combine together on top using the product rule. So y to the power of 10 times y to the power of 5 is y to the power of 15 all over x. And there's my final simplified fraction. Now looking at this example, my suggestion was to simplify each fraction at the very beginning in the separate brackets first. However, if we had wanted to, we could have applied this power in at the beginning to each piece, and we could have done that and got the same result. As long as we don't break any math rules, you can use these rules in different orders and get the same result. So if your instinct's a little different than mine, or this is just the way you want to tackle the problem, you can do that. You can apply that exponent first to each, apply the exponents to each bracket first, and then continue on the problem. And you're welcome to do that. But whichever way you decide to do it, the important part is just that we're not breaking any of these exponent rules that you've learned about as you go.